Hi everyone. In the given problem statement, we are going to solve minimum absolute difference in a binary search tree. So we are going to given a root of a binary search tree. We have to return the minimum absolute difference between the values of any two different nodes in a tree. So in order for us to solve this problem, let me draw the binary tree, which would be 4, 2, 6, 1, and 3. The first thing that I'm going to do, right, is going to take all the nodes that are available. So all the values of our nodes that are available and store it in a queue. We can use BFS or DFS to traverse the entire tree. So let's say if I use BFS, right, we are having the root node 4, then it is having two more children, 2 and 6, and then another two more children, 1 and 3. And if you're not aware, right, how we are going to use BFS, you can look into the previous problems that I have solved. So basically we are going to use a DQ where you're going to store the values, and we are going to store all those values. Once I go to the Python solution, it would be very clear to you. Now once I've got that right, I can sort these entire values in ascending order. So value would be 1, 2, 3, 4, and 6. Once I've done that, the absolute difference between 1 and 2 would be 1, 1, then 1 and 2. This would be the absolute difference between the elements. So the lowest most, right, is 1. So we're going to return 1 as a result. So that's the idea how we are going to get the minimum absolute difference in a binary search tree. Basically traversing all the nodes, store it in a DQ, and then find the minimum absolute difference. Now let us jump to the Python solution. So the first thing we're going to check is if not root, then we are going to return an empty list or empty value, or let's say we're going to return none. Once that is done, we can create a queue, which would be, let me import two more packages. One would be import collections, and then import math. Then queue would be collections dot dq, and we're going to have the root out here, and then result would be the empty one, and the mean difference is going to be math dot infinity. So I have to take the difference, which is the lowest. So while we have value in our queue, and we are going to have a temporary list, and we are going to traverse. So for underscore in range 0 to length of our queue, cur equal to q dot pop left. So we're removing the first element, and we are going to add that value to our res dot append cur dot val. So you don't be requiring this temporary list, sorry for that. And now we are going to check if our node has any left child. So in case it has, then the value would be q dot append cur dot left. In case if it has right child, cur dot right q dot append right. Once that is done, the value would be res equal to sorted result for I in range 0 to length of res minus 1 temp diff equal to result of I plus 1 minus result of I if temp diff less than the minimum difference min difference equal to temp diff. We have to return our minimum difference or the minimum absolute difference in a binary tree. So di difference. So here, right, we are getting all those values, traversing the entire nodes of our binary search tree, storing those values into a result, sorting it up, and after sorting right, we are checking what basically what is the absolute differences. So the time complexity of this problem would be big O of n, because you're traversing the entire nodes of the binary search tree once, and also there is one more loop that is happening. There is also one for happening for the sorting, but after that also, to find the minimum difference, right, we are again traversing it up. So you can say it would be 3 big O of n in that range. Now if I run it up, it is showing it's bit 100% the submission. So it is pretty efficient in all those parameters. That's all for this video. See you in the next one.